All right, buckle up, everybody, because today we are diving deep into a recent discovery that sounds like something straight out of a sci-fi thriller. We're talking about a black hole.
That's right.
Not just any black hole, though.
Right.
This one isn't content with just passively swallowing a star. It's ripping it to shreds and then using the pieces like ammo to blast something else nearby.
Yeah. It's pretty intense, and what makes this even more exciting is that it's not just about witnessing some crazy space violence. It's helping scientists connect two separate cosmic puzzles they've been trying to solve.
So we're talking about observations from the Chandra X-ray Observatory. And I think anyone who follows astronomy knows that when it comes to high-energy events like this, Chandra is definitely the telescope to watch. So before we get too deep into the details, can we take a step back and, set the stage a bit? What exactly are we looking at here?
Well, first, we need to introduce the star, or I guess what's left of it.
Okay.
It's called AT 2019 Quiz, and it's a system with a black hole at its center, about 210 million light years away. Back in 2019, astronomers saw this black hole doing what black holes do best.
Oh, I like where this is going.
Causing chaos.
All right. Black holes, they're messy eaters, we get it. But what kind of chaos are we talking about specifically in this case?
This particular mess is what astronomers call a tidal disruption event, or TDE for short.
Okay.
Imagine a star getting a little too close to a black hole. The black hole's gravity is so strong that it stretches the star like pulling taffy.
Oh, yeah. Cosmic spaghettification. I've heard about this.
Exactly. The star gets stretched so much it can't hold itself together and it just gets ripped apart.
Ouch.
Initially, astronomers thought that's all they were seeing with AT 2019 Quiz, just a regular TDE.
Okay, so we have our star getting shredded by a black hole, which, let's be honest, is already pretty wild.
Yeah.
But you mentioned two mysteries, right?
Yes.
So what's the other piece of this puzzle?
So around the same time, astronomers were observing these short, regular bursts of X-rays coming from the areas around other supermassive black holes. And here's why X-rays are so important. The stuff swirling around a black hole gets superheated and blasts out radiation, including X-rays. So they're kind of like a beacon.
I see.
Signaling that something extreme is happening.
Okay, so it sounds like they were seeing these two weird things happening at once, a star getting torn apart,
Right.
and these X-ray bursts, which they called, what was it, quasi-periodic eruptions.
Quasi-periodic eruptions, or QPEs.
QPEs. Okay, so, but what does one have to do with the other?
Yeah, that's the question that had everyone stumped.
Right.
It seemed like these two phenomena, the TDEs and the QPEs, were totally unrelated, but here's where it gets really interesting. Scientists now believe that the TDE and the QPEs in AT 2019 Quiz are actually connected.
Oh, really?
Yeah.
Okay.
And the evidence comes from some incredible teamwork between multiple telescopes.
Multiple telescopes. Oh, this is where it gets juicy. What did they find? Spill the tea.
Well, the Chandra X-ray Observatory, along with Hubble, NICER, SWIFT, even India's AstroSat all played a role.
Wow. A real team effort.
Yeah, it was great. Chandra detected changes in the X-ray signals that pointed to a specific event. Meanwhile, NICER revealed that these X-ray bursts were repeating roughly every 48 hours. And then Hubble, amazing Hubble, helped astronomers figure out how big that disk of debris from the shredded star had become.
Okay, so wait. You're telling me that this cloud of shredded star stuff is somehow connected to those X-ray bursts. How does that even work?
So picture this. You've got this giant glowing frisbee of star stuff.
Okay.
The remains of the shredded star.
Uh-huh.
And it's expanding further and further out from the black hole. Anything orbiting the black hole within a certain distance is going to run right into it.
Oh.
And those collisions are what's causing the X-ray bursts. It's like the black hole is using the star's remains to play a cosmic game of skee-ball.
Are you kidding? So the black hole isn't just destroying a star, it's using the leftovers as ammunition to blast something else nearby.
Exactly.
That's even cooler than I thought. But what does this all mean in the grand scheme of things? I mean, why should we care about one black hole's crazy antics millions of light years away?
That's a great question. Well, for starters, it gives us some pretty strong evidence that TDEs and QCEs are linked.
Okay.
Which is a big deal because astronomers weren't sure about that before. It's like finding a missing piece of a puzzle.
Okay. So it helps us understand the bigger picture. But what else? What other secrets can we unlock by studying these events?
Well, think of it like this. Now that we know these events are connected, we can use them to study what's happening around other supermassive black holes, like what kinds of objects are orbiting them and how these systems behave.
All right, so we're learning more about the neighborhoods surrounding these black holes. But you mentioned something earlier about gravitational waves.
Right.
Does this discovery have any implications for that kind of research?
Absolutely. These collisions, if they involve really dense objects like neutron stars or even smaller black holes, could be sending out gravitational waves, which are basically ripples in the fabric of spacetime.
Wow, so we might actually be able to hear these collisions through gravitational waves? That's amazing. But before we get too carried away with the possibilities, I think it's a good time to take a step back and recap what we've learned so far, just to make sure we're all on the same page.
Sounds good. So we started this deep dive by introducing you to a supermassive black hole with a taste for destruction. This black hole, located in a galaxy roughly 210 million light-years away, was caught in the act of shredding a star, creating a tidal disruption event, or TDE.
Right. And just to refresh everyone's memory, a TDE happens when a star gets too close to a black hole and gets literally pulled apart by those immense gravitational forces. Like watching a cosmic spaghettification in action.
Quite right. And alongside this TDE, astronomers observed another intriguing phenomenon, those short, regular bursts of X-rays, which we now know are called quasi-periodic eruptions, or QPEs. Remember, those X-rays are crucial because they signal that something extremely energetic is happening near the black hole.
And here's the real kicker. It turns out these two seemingly unrelated events are actually connected. The debris from the shredded star, which formed this swirling disk around the black hole, is being used as ammunition to bombard another object in the vicinity, probably another star, or maybe even a smaller black hole.
Exactly. It's these collisions between the debris and this other object that are causing those observed X-ray bursts. It's almost like the black hole is playing a cosmic game of pinball, using the remnants of a star as its projectiles.
It's mind-blowing to think about the sheer scale and power of these events. We're talking about a black hole, an object so dense that not even light can escape its grasp, using the remnants of a star to blast another object millions of miles away.
It really highlights the dynamic and often violent nature of the universe, especially in the vicinity of these supermassive black holes. It's not just a peaceful, static environment. It's a place of constant interaction and, in this case, destruction.
But what's truly remarkable about this discovery is that it's not just about witnessing a cool cosmic event, right? It has significant implications for our understanding of black holes and their role in the universe. Would you agree?
I would absolutely agree. In fact, this discovery helps us to connect TDEs and QPEs and potentially solve a puzzle that has lingered in astrophysics for quite some time. You see, before this, astronomers weren't sure if these two events were related, but now they have compelling evidence to suggest that they are.
It's like finding that one missing puzzle piece that suddenly makes the whole picture clearer, right? This discovery is helping us create a more complete picture of the complex processes happening around black holes. And not only that, it's opening up new avenues of research. What other mysteries of the universe do you think we can unlock with this new knowledge?
Well, for one, now that we know these events are linked, we can use them to study the environments around black holes in more detail. We can learn more about the types of objects that orbit black holes, the dynamics of these systems, and how black holes interact with their surroundings. But there's so much more. This discovery also has implications for the future of gravitational wave astronomy.
Okay, before we get ahead of ourselves and dive into the world of gravitational waves, I think we should wrap up this part of our deep dive and take a quick break. We'll be back soon to continue exploring the fascinating implications of this cosmic discovery. Don't go anywhere. Okay, so before the break, we were talking about how this black hole is basically playing a cosmic game of pinball with the remains of a star. But you mentioned that this discovery, this whole thing, could also be a big deal for the study of gravitational waves.
Oh, absolutely.
Can you unpack that a bit more for us?
So gravitational waves, as you may know, are like ripples in the fabric of space-time. And they're created by incredibly massive objects moving around each other. Now, if these collisions we're talking about, the ones between the star debris and this other object near the black hole, if they involve something really dense, like a neutron star or even, another black hole, they could be strong enough to actually generate gravitational waves.
So it's like the black hole is causing these crashes that send out ripples in space and time, and we can actually detect those ripples here on Earth with, those special observatories.
Exactly.
That's pretty mind-blowing.
It is, and as our gravitational wave detectors get even more sensitive, we might be able to pick up these signals from events like AT 2019 quiz, which would give us a whole new way to study black holes and the extreme environments around them.
Wow.
It'd be like listening to the universe instead of just looking at it.
Okay, so we've talked about how this discovery connects two different phenomena, TDEs and QPEs, and how it could help us understand the surroundings of black holes and even detect gravitational waves. But I'm curious, what does all this actually mean for us here on Earth? Like, why should we care about a black hole having a snack millions of light years away?
Well, that's a great question. And it might seem like these events are happening in some distant corner of the universe and have nothing to do with our everyday lives. But here's the thing, studying these extreme environments where gravity is so strong, it warps space and time, it helps us to push the boundaries of our understanding of physics.
So it's like we're testing our theories about how the universe works in the most extreme laboratory imaginable.
Exactly.
And that knowledge could lead to new discoveries and technologies down the road. I mean, think about it. Einstein's theory of general relativity, which describes gravity, has led to all sorts of technological advancements, like GPS. We might not see immediate practical applications from studying black holes tearing apart stars, but who knows what the future holds?
Right. It's like when people questioned why we should go to the moon.
Yeah,
At the time, it seemed like this huge, expensive endeavor with no clear payoff. But it led to all sorts of innovations that we benefit from today.
exactly.
Yeah.
So it's not just about understanding black holes. It's about expanding our knowledge of the universe as a whole
Yeah.
and pushing the limits of human ingenuity. I like that.
And remember, we've only just begun to scratch the surface. This discovery is just one piece of the puzzle. I mean, if one black hole is doing this, imagine how many other similar events are happening out there in the vastness of space.
It's mind-boggling. It's like we've stumbled upon a cosmic feeding frenzy with black holes all over the universe, tearing apart stars and using the debris as weapons. And each one of those events is a potential window into, the most extreme physics imaginable.
Exactly. And with every new observation, every new discovery, we're peeling back another layer of the cosmic onion, revealing a universe that is far more dynamic and complex than we ever imagined.
So you're telling me that we're living in a universe that is constantly in motion, constantly evolving, constantly surprising us with its wonders, and that there's so much more out there to discover, so many more secrets waiting to be unveiled.
Absolutely.
Sign me up.
Well, I think we've got a budding astronomer on our hands. But you're right. This discovery is a perfect example of how scientific exploration, of pushing the boundaries of our knowledge and understanding, can lead us to a deeper appreciation of the universe and our place within it.
It really makes you wonder what other mysteries are lurking out there in the depths of space. What other cosmic phenomena are just waiting to be discovered? And how will those discoveries change our understanding of the universe and of ourselves? I don't know about you, but I'm getting pretty excited just thinking about it.
Well, that's the beauty of science, isn't it? The journey of discovery never truly ends. There's always something new to explore, something new to learn. And we as a species are fortunate to be a part of that journey.
I couldn't agree more. So for all of you listening out there, the next time you look up at the night sky, remember that amidst those twinkling stars, there are black holes, these enigmatic objects shaping the cosmos in ways we're only just beginning to understand. And who knows, maybe one day you'll be the one to make the next groundbreaking discovery that unlocks even more secrets of the universe.
That's right. Keep looking up and keep asking questions. You never know what you might find.
Couldn't have said it better myself. And that brings us to the end of our deep dive into this incredible cosmic discovery. We hope you enjoyed this journey into the heart of a black hole's chaotic antics. Until next time, keep exploring the wonders of the universe. It's pretty amazing to think that we're, living in a time when we can actually observe these events happening millions of light years away. It's really all thanks to these incredible advancements in technology and the dedication of all these scientists around the world who are working on this stuff.
Oh, absolutely. I mean, the fact that we can use telescopes like Chandra and Hubble and NICER to actually peer into the distant universe and witness these events unfolding, I mean, it's really a testament to human ingenuity.
Yeah, for sure. And, speaking of those telescopes, I got to say the collaboration between all those different observatories to gather the data for this discovery,
Yeah.
it's pretty impressive. It's like they all came together to solve this cosmic mystery.
Absolutely. I mean, this discovery was a result of a global effort with scientists from multiple countries all pooling their resources and their expertise to make this happen. And, it just goes to show that when we work together, we can achieve some incredible things.
Right. So let's bring it back to our listener for a moment. We've thrown a lot of information their way about black holes and tidal disruption events, these quasi-periodic eruptions, and even gravitational waves. What's the one big takeaway you think they should walk away with from this deep dive?
Well, I think the biggest takeaway is just that, the universe is a far more dynamic and complex place than we often give it credit for. There are these incredibly powerful objects out there, like black holes, shaping the cosmos in ways we're only just beginning to understand. And, with every new discovery, we're getting closer and closer to unraveling the mysteries of the universe and our place within it.
Yeah, it's not just about learning some cool facts about space, right? It's about realizing that we're part of something much bigger than ourselves, this vast and ever-evolving universe that's full of wonder and surprises. That's pretty inspiring, don't you think?
I couldn't agree more. I mean, it's a humbling experience to study the cosmos and to realize how much we still don't know.
Right.
But, that's also what makes it so exciting.
Yeah.
There's always something new to discover, something new to learn.
And that brings us to the end of our deep dive into this incredible cosmic discovery. We hope you enjoyed this journey into the heart of a black hole's chaotic antics.
And remember, keep looking up at the night sky and keep asking questions. You never know what mysteries you might unravel.
Couldn't have said it better myself.
Yeah.
So until next time, keep exploring the wonders of the universe.